Hello. So in this video, we're going to be talking about the specifics about how limits exist. And in particular, we're going to sort of introduce this idea of right and left limits. So in general, when talking about limits, we've seen before this idea of being sort of close enough, or this arbitrary closeness, was the game. That was what made everything work. That's what we really wanted to understand. We needed to get as close as we could to this point, but sort of not at the point, right? Limits, we don't care about the value at the point, but we have to be arbitrarily close, right? So for limits then, it seems like all we care about is the distance, which is true at a conceptual level. But it turns out that sort of mechanical level, it's really helpful to break down this idea of a limit into a left and right part. So in general, when we want to talk about a limit, we say the limit exists if the left and right limits both exist and equal each other. So here, the right and left limits are sort of not cleverly named. They're exactly what we would think they are. So a left limit is when we are looking at the limit from the left, meaning we're sort of approaching that x value from below the x. And the right limit is exactly the same idea, but from the right. So we're approaching that x value from the right, or from above the x value. Okay. So knowing this, both exist and equal to each other, this means if you're thinking to yourself, okay, does a limit exist at a point? This should sort of immediately spark these two ideas. Do both one-sided limits exist? If so, are they the same value? This is exactly the sort of mantra, the step-by-step you want to think of. And to be clear, this is a question about existence. So we might have, you might have an example problem, and you'll see some videos on this where it's like, compute this limit, right? And that'll be a slightly different process. But when we are only asking okay, does it exist? This is exactly the steps that you want to think. Do both one-sided limits exist? If so, are they the same value? So let's look at an example so we can see sort of what we're talking about when we talk about this left and right limit. So here we have this sort of mostly continuous function, right? So we're sort of starting up here and we come down and around. We have a hole right here at 1, and then we keep going, right? So if we want to sort of know the obvious part here, does the limit exist at x equals 1? So if we're looking at that part, then we're going to look at the limit from the left, meaning from the left side of the 1. And to do that, we follow the curve from the left side on the x value, and we see, okay, we come up to this y equals 0 part, right? Coming up to that point. Then we look at the right limit. So if we're looking at the right, we follow from above the x value, right? So I'm thinking of it not above in terms of, up and down, but above in terms of to the right of the x value that we want. So bigger than 1. We follow this curve down. We see it also comes to y equals 0. So the left limit exists, it equals 0. The right limit exists, also equals 0. And that tells us that the overall limit does exist and equals 0. Okay. In contrast, we have an example here where if we are looking at, say, the limit as x goes to 1, this vertical asymptote here, which is hard to sort of highlight, but where these two things are sort of separated, same process. We ask, okay, does the limit exist at x equals 1? So I start with whichever, to be clear, you can do whichever side you want first. So let's maybe do limit from the right. So if I look at from the right, that means I want to the right of that x equals 1 line, right? The bigger side for the x. And I come along that curve and I see, okay, I'm going up, up, and away, like, Superman going way too high up, right? So that's going to positive infinity. In contrast, if we look at the x values from the left, right? So we're looking at to the left, or more negative x values. Then we're going to follow the curve. Again, we're going to look at as we go down. And so here we can see, right, that we're going to go down to negative infinity. So we have the limit from the right going off to that positive infinity, the limit from the left going to negative infinity. These are not the same thing. This tells us the limit does not exist, okay? So in general, when we're talking about whether or not a limit at x naught, or this x sub 0 exists, that means that we have these pieces, right? The limit from the left exists, the limit from the right exists, and those two things have to agree. That's what it means to say that a limit exists at a point. Conversely, saying a limit does not exist means one of two things. Either at least one of the one-sided limits doesn't exist, or one of the one-sided limits, or they do both exist, but they are not equal, right? So if they go to different values, like positive, negative, infinity, but even less dramatic. So if one goes to 2 and one goes to 5, if they're not equal, that tells us that they don't exist, okay?